Good morning. Today, now let us see about the plane. Now, if the line completely lie on a surface, then you can say it is the plane. And now let us see the first equation of the plane in normal form, means the distance of the plane for the origin is given and normal to the plane is given. So now let us see how you find the equation of the plane in normal form. In this, to find the equation of the plane in the normal form, here you see, to find the equation of normal form, this is x-axis, y-axis and z-axis. To find the equation of a plane, let this will be plane and the distance d from the origin, this is origin of the plane, and the distance of the normal to the plane d is given. This is the ON is normal to the plane, this ON is normal to the plane, the distance of the plane from the origin is given. Let this will be d, distance of d is plane is given. Let P be any point on the plane. Let P be any point on the plane with position vector r. With position vector r, and then the d is the distance of the plane from the origin. This d is the distance of the plane from the origin, and d is not equal to 0. On is what? On is normal to the plane from the origin, and let n is the unit vector. The d and d is what? Distance of the plane distance of the plane from the origin. ON is normal to the plane, normal to the plane, ON is normal to the plane, unit vector, in the direction of normal to the plane, in the direction of normal to the plane, and d is the distance from the origin. Then here is the np and dot on. Then here np dot on. np this np is perpendicular to on. On is the normal to the plane, and np is lie on the plane. The NP is lie on the plane and ON is normal to the plane. NP is in this form and this is the perpendicular. The ON is perpendicular to the NP. So that their dot product NP dot ON. The NP dot ON that will be equal to 0. So their dot product is equal to 0. The NP is what? R minus dn. Vector R minus dn. Unit vector n. dn is in the direction of ON. The R minus dn. ON is what? D unit vector n. That will be equal to 0. And here what happened? D is the distance from the origin and D is not equal to 0. So if D is not equal to 0, then we can write R minus D unit vector n dot unit vector n equal to 0 because D is not equal to 0. Now if you write the dot product, then you can write R dot unit vector n equal to D unit vector n dot unit vector n. Here what happened? Unit vector n dot unit vector n, that will be equal to n. So that we can write R dot unit vector n equal to D. So this is the vector equation of the plane. So this will be the vector equation of plane. So this is what? Vector equation of plane. So this is the vector equation of plane. Now let us see how you find the Cartesian equation of plane. Now here you see, if you write R, this vector R in the Cartesian form, if the point P is given in the component form, this is the component form xi, yj and zk. This will be given the vector R, position vector of P, and n is given, unit vector n is given, that is Li, Mg and K. This will be given, then R dot n. The R dot n, the distance from the origin is given, then equation of plane in normal form, that is the Lx, then we can write what? Equation of plane, in Cartesian form. The equation of plane in Cartesian form, that is the normal form. Normal form and Cartesian form, that is what? Lx plus my plus nz equal to d. So now here you remember the coefficient of x, y, z. The coefficient of x, y, z is direction cosine of the plane. Here L, M, N. If the plane is in the normal form and this is the in the unit vector form, R dot N. If the equation of plane is in the normal form and D is the distance from the origin, then coefficient of x, y, z is the direction cosine of the plane. So this is the equation of plane in the what? Cartesian form, in the normal form, and this is the vector equation of the plane in normal form. This is the equation of plane in Cartesian form. This is the normal form and is in Cartesian form. Okay. So now let us see next the equation of plane. Equation of plane perpendicular to a given vector and passing through a given point. Now let us see second equation of plane. Equation of plane perpendicular to a equation of plane perpendicular to a given vector and passing through a given point and passing through a given point. The equation of plane perpendicular to a given vector and passing through a given point. So how do you find the equation of a plane passing through a given point and perpendicular to a given vector? Because the plane, just as this is the plane and this is the plane passing through a given point, हमें कहाँ पर छत डालना है ये निश्चित होना चाहिए और किस डायरेक्शन में डालना है, मतलब गिवन परपेंडिकुलर टू ए गिवन प्लेन, तो परपेंडिकुलर टू ए गिवन वेक्टर पासिंग थ्रू ए गिवन पॉइंट, मतलब कितनी ऊंचाई पर डालना है और किस डायरेक्शन में डालना, ऐसे डालना है कैसे डालना है कि इस परपेंडिकुलर पर डालना है, तो इसके परपेंडिकुलर डालना है, इस पॉइंट पर डालना है, किस पॉइंट पर डालना है, तो ये हमें मालूम होना चाहिए 5 मीटर पर डालना है कि 6 मीटर पर डालना है कि 10 मीटर पर डालना है और परपेंडिकुलर डालना है. तो द परपेंडिकुलर डायरेक्शन इज गिवन एंड पॉइंट इज गिवन. The equation of plane passing through a given point and perpendicular to the plane is given. So how do you find the equation of a plane passing through a given point and the perpendicular to a given vector? So now let us see. X, Y and Z. To find the equation of plane passing through a given point, this plane is given and equation of a plane passing through a given point let this plane passing through a point. This point, let this plane is passing through a given point, and this plane is passing through a point E, with position vector of this plane is given. Position vector of this plane is given. Position vector of a plane is given. The plane passing through a given point A, and normal to the plane. Normal to the plane is given. Plane is perpendicular to the N. Perpendicular to the vector N. This plane is given perpendicular to the vector N. So now we consider any point on the plane. So let a point P on the plane. Let this point, any point P on the plane. Let this point P on the plane. Let this point P on the plane. Point P with position vector R. Position vector of this point P. Point P is given with position vector R of this plane is given. So then you find the equation of the plane. The R with the position vector of the point P, and this point P is given X, Y and Z. So we want to find the equation of the plane, and normal to the plane is given. So this normal to the plane is given, and vector A. This plane passing through the point A, and now we consider a point P on the plane. So then AP lie on the plane, and N is the normal to the plane. Then what happened? This AP is perpendicular to the N. So now we consider AP is perpendicular to the N. R with the position vector of point P. The vector R is the position vector of point P. So then what happened? A is a point. A is a point. Plane passing through the point A. Plane. Let plane passing through a point A with position vector A, with position vector A. Consider a point P. Consider a point P on plane with position vector R. N is normal to the plane. N is normal to the plane. Therefore, what happened? Therefore, AP dot N, therefore vector AP dot N equal to 0. Equal to 0. AP, what is AP? What is this AP? R minus A. The R minus A, vector R minus A dot N equal to 0. So this is the vector equation of a plane passing through a given point and perpendicular to a given vector. So now we can write this in the Cartesian form. How to write the vector in the Cartesian form? We can write the vector in the Cartesian form. If n is given, normal to the plane is given, normal to the plane is given. Here you see R is given, vector R is given, xi plus yj and zk. This is A. Vector A is given, x1i, y1j and z1k, and normal vector n. Normal vector n is given, ai plus bj plus ck, where a, b, c is the direction ratios of the normal to the plane. So that Cartesian form of the equation of the plane, we can write a x minus x1, a x minus x1 plus b y minus y1 plus c z minus z1 equal to 0. So this will be the Cartesian equation of the plane passing through a given point and perpendicular to a given vector. So this is the Cartesian equation of the plane. Passing through three non-collinear points. Now let us see equation of plane passing through three non-collinear points. Now let us see equation of plane passing through three non-collinear points. Now let us see equation of plane passing through three non-collinear points. Let the plane passing through the point R, plane passing through the point three non-collinear point R, and yes, find the plane passing through the three non-collinear point R, S and T. The plane passing through the three non-collinear point, this is R, here is the point S, S, and here is the point T. Find the plane passing through the point R, S, and T. The plane passing through the three non-collinear points R, S, and T. R, S, and T. So that is the R, S, and T. Here you see R, S, and RT. RS and RT. The cross product of this RS and RT is perpendicular to the RS dot RT. Cross product of this RS and RT. Cross product of RS and RT is what? This cross product of RS and RT is perpendicular to the plane in this direction. This is perpendicular to the plane, mean above the board, above the paper, upwards in the upwards direction. So this is the equation of plane passing through the 3 point. Let P is the any point in the plane. Let P be a point in the plane with position vector R. P be a point with position vector R, and the position vector of this OR, position vector of OR, that is A, this is A, and position vector of RS, this vector S, the position vector of RS, that is a vector, this is vector B, and this is vector C. This is vector C. Then what happened? We can write the equation of this. The OR, RST are three non-collinear point. R, suppose let R, S, P, R, R, S, P are three non-collinear points on the plane with position vector OR, that is vector A, OS, that is vector B, and OS, that is vector B, and OT, that is vector C with position vector C. Now consider a point P on the plane. Consider a point P with position vector R, consider a point P with position vector R on the plane. Therefore, what happened? R minus E is what? R minus E is this RP, vector RP. The RP means that vector PR. The R minus E, vector R minus E is what? Vector RP. This vector RP. R minus E. The R minus E is this vector RP. R minus E dot RS into RT. R minus E dot vector RS RT. This vector, that will be equal to 0. So we can write this R minus E RS is what? B minus E vector RS cross product of RT. RT is C minus E vector C minus E, that will be equal to 0. So this is the vector equation of the plane passing through three non-collinear points. So this is the vector equation of plane passing through three non-collinear points. So we can write this in the Cartesian form. If vector R is given xi, yj and zk, vector A is given x1i, y1j and z1k, vector B is given x2i, y2j and z2k, and position vector of C is given x3i, y3j and z3k. Position vector of these are given. Position vector of R, S and T. Position vector of R, S and T is given. Position vector of R is given x1, y1, z1. S is given x2, y2, z2. And C is given x3, y3 and z3. Then we can write the Cartesian equation of the plane in this form: x minus x1, y minus y1, z minus z1, and in this way x2 minus x1, x2 minus x1, y2 minus y1, z2 minus z1, and here x3 minus x1, y3 minus y1 and z3 minus z1, that will be equal to 0. So this is the equation of plane passing through three non-collinear points. So now you remember this equation of plane passing through three non-collinear points. So now let us see intercept form of the equation of plane. That is 4 intercept form of the equation of plane. So now you know the equation of plane. Plane make the intercept on x-axis, y-axis and z-axis. Plane make the intercepts on x-axis, y-axis and z-axis. Let it will be make the axis P, Q and R. Make the intercept on x-axis, y-axis and z-axis. Then coordinate of this point A 0 0 and that is what 0 B 0 and this will be what 0 0 and C. So this is the intercepts made by the plane on x-axis, y-axis and z-axis. A intercepts on x-axis, B intercepts on y-axis and C intercepts on z-axis. This is same just as in 2 dimension. You have learned light makes the intercept on x-axis and y-axis, then equation of line is what x upon a plus y upon b, that will be equal to 1. So that is the same. Now you know the equation of plane. Equation of plane, what? You know the equation of plane in normal form. The equation of plane in normal form, equation of plane in normal form, the Cartesian equation of plane in normal form is what? Ax plus by plus cz, ax plus by plus cz. Now you know that plus d equal to 0. D is not equal to 0. The d is not equal to 0. So now you know that the equation of plane. So now if this plane passing through the point A, so passing through the point A, then 0 0, so AA, this will be 0 plus D, that will be equal to 0. So then you can determine this with A equal to what? This implies that what? A equal to minus D by E. A equal to minus D by E. Similarly, it passes through the y-axis, make the intercept on y-axis, then you can get what? BB plus D, that will be equal to 0. It means that B equal to minus D by B, and it passes to the z-axis and make the intercept on C, so that the other coordinate will be 0, that is the C plus D equal to 0, so that you can write C equal to minus D by C. Now put this value in the above equation. So now if you put this value in above equation, then you can get what? Putting this value, putting this value in above equation, we get what? X upon A plus y upon B plus z upon C equal to 1. So this is the equation of plane. Make the intercept A, B and C on x-axis, y-axis and z-axis. This is in the same way as the line make intercept on x-axis and y-axis in two dimensions, then the equation of line is what? X upon a plus y upon b, that is a 1. In the case of plane, it will be at z upon c. The x upon a plus y upon p plus z upon c, that will be equal to 1. So this is the intercept form of the equation of plane. Thank you.